Little bit of a cheeky question. Can take a little bit more time. I'm going to take a little bit longer than 5 minutes to answer this. But the height of a baseball after it is hit by a bat is modeled by the function negative 4.8 t squared plus 21t plus 1.2, where ht is the height in meters above the ground and t is the time in seconds after the ball was hit. Write down the height of the ball above the ground at the instant it was hit by the bat. Okay, so in this case, what is being implied is that the time is going to be 0. So at the instant that it's hit by the bat, that's when the model actually starts happening. So we're looking for h of 0. If we substitute 0 into all of those bits, negative 4.8 times 0 plus 21 times 0, we're just left with 1.2. So the height the height at which the ball is being above the ground is 1.2 meters when it's hit. Find the value of t when the ball hits the ground. Okay, so if we realize what's happening there, that shouldn't really have taken a minute, but what we're going to do is reach for the calculator and we're going to use graph. We're allowed to graph this, so let's throw in negative 4.8. I need to remember to change to x for this, plus 21x, and then plus 1.2. I'm expecting to see a negative quadratic that passes through somewhere here, so I'm hoping something like this. We're hitting a ball, and that's what we get. So find the value of t when the ball hits the ground. So the ball's thrown, it goes up, it goes off our screen at the minute, but then comes down and hits here. So what we're really looking for is when the model equals 0. So we have 0 equals negative 4.8 t squared plus 21t plus 1.2. So menu, analyze graph, 0, left, right, gives us a value of t is going to be 4.43 seconds. C, state an appropriate domain for t in this model. Okay, so t is representing the time in seconds after the ball was hit. The domain. So the domain are the values of time. So the model can't exist in negative time. So our model for t must include 0. And the ball goes all the way in the air until it lands at 4.43 seconds. And the time has to be less than that, but inclusive of that, because that is when it hits the ground. So these values from here to here would represent our domain.